Okay, this is Unit 1, Lesson 4. What we're talking about today are special factoring formulas. Those are a squared minus b squared, which is called the difference of two squares. And then we have a squared plus or minus 2ab plus b squared. That is just a binomial that has been squared. Okay, so what we're going to look at, or first off, we'll start with a little bit of information. Okay, so first thing we want to recall is from algebra. You were told that the shortcut for factoring a trinomial in the form that's a squared plus or minus 2ab plus b squared is this. Okay, so what you got, the first one is two numbers added together squared, and the second one is two numbers subtracted squared. So the first one gives you a squared plus 2ab plus b squared is equal to the a plus b in parentheses squared. So this is the same as a plus b in parentheses times a plus b in parentheses. Okay, the second form is a squared minus 2ab plus b squared is equal to parentheses a minus b in parentheses squared. Okay, so these two forms, this gives you a pattern. So if you notice, it said plus or minus in the thing we were talking about up at the top. The first line is the plus part of that. The second line is the minus part of that. And notice that the sign on the middle term is determined by the sign that's between the two numbers that are being squared. Okay, so the first thing we want to do is multiply x minus 5 and square it. Okay, so what this means is it's the same as writing x minus 5 in parentheses times x minus 5 in parentheses. So here's our pattern that we had from the previous slide, and it says that parentheses a minus b squared is equal to a squared minus 2ab plus b squared. What they're telling you with this pattern is that you don't have to physically sit down and multiply each of it out like you've been doing in the past with the other things that we talked about, or that you can factor it from directly this form back to that form. Okay, so whichever one you need. So we had x minus 5 in parentheses squared. So using the pattern, the first term gets squared, so that's x squared. The second term gets squared at the end of it, so that's going to be plus 5 squared, because when you multiply a negative number times a negative number, you get a positive number, and we still need to square it. And then the thing on the middle is minus, because that's what's between the two terms, and then we're going to put 2 times x times 5. Okay, so that leads us to the result, which is, after we simplify, which gives us x squared minus 10x plus 25. Okay, once again, if you have any questions about these things, write them down on the side of your notes and bring it to class tomorrow, and we'll be glad to discuss them before we start. Remember, there's a parking lot if you don't want any people to know who you are, or you can ask a question directly in class, whichever makes you better, fits you better. Okay. Okay, example 2 is a little bit more complicated because this time they've got a bunch of numbers involved in it too, but it's still a plus b, and that's in parentheses squared. So we're going to use the pattern which says that a plus b in parentheses squared gives us the result a squared plus 2ab plus b squared. Okay, so we're going to do just like we did before. We're going to take the parts. Okay, the first part of the a is represented by 3y. So that's going to give us 3y squared plus 2b. Okay, that's the last term, is the last term over here, and that's going to be 2b squared. Then we're going to multiply these together and multiply by 2. So we have 2 times 3y times 2b. Okay, when we simplify that, squaring this gives us 9y squared. Taking care of the middle term, 2 times 3 times 2 gives us 12. And then we have y times b. Then we also have over here, when we square the 2b, we get 4b squared. Okay, so let's go ahead and see where this leads us to for the next example. Okay, so example 3, this time instead of multiplying, they want us to factor this trinomial. Notice we have x squared, so that's a perfect square. The last term is 16, which is also a perfect square because that's 4 squared. And then we have something in the middle that's negative 8x. Okay, since 8 is equal to 4 times 2 and x is equal to the first term, then we know it fits this particular pattern. So we're going to write our pattern down that says that a squared minus 2ab plus b squared equals parentheses a minus b in parentheses squared. Okay, so take the square root of the first one, so the square root of x squared is x. The square root of 16 is 4, so it becomes x squared, and then we're going to turn it into 2x times 4, so that gets the 2 out, and so we also have a 4 squared. Okay, so that means that this ends up being the reverse of x minus 4 squared. Okay, example 4. This time we have the example that has the plus sign on the middle term. And look, notice that the first term is m squared, so that's a perfect square. The square root of that is m. The square root of 81 is 9. So 9 times 1 times 2 gives us 18, so that means this middle term fits the pattern again. So we're going to write our pattern down again, this time with the plus sign. So we have a squared plus 2ab plus b squared equals parentheses a plus b squared. So we're going to take the square root of the first term, square root of the last term, put them into these two, and then we're going to divide the middle one by 2 and leave the variable there also. So this is going to give us m squared plus 2m to the 9th plus 9 squared is another way to write this original trinomial. So since it fits the pattern that we wrote here in the middle, we're going to know that we just take the first term and the last term, put them together with a plus sign, m plus 9, put it in parentheses, and square it. That's our factor. Okay. Second thing we need to talk about is the other form that we talked about right at the very beginning, the difference of two squares. So this time you have two little numbers, okay, that have a negative sign between them. It's very important that it has the negative sign there before you try to use this one. So this gives us a squared minus b squared is our original thing. So we have a squared minus b squared, and that will factor into a minus b in parentheses times a plus b in parentheses. Okay, so that's our shortcut. So example 5, this time they're wanting us to multiply these together. Notice they're exactly the same except the sign in the middle between these two is different. So that's going to give us the difference of two squares. So we square the first term, which is p, and we square the last term and put a negative sign between them because positive times a negative is a negative. Okay, so a minus b in parentheses times a plus b in parentheses equals a squared minus b squared. That's our pattern. Okay, so since this fits the pattern up there, we're going to take p minus 7y times p plus 7y. We just reversed the way that it was written so that it would fit our pattern. So we take the first term, which is p squared, take the second term, which is 7y. Okay, the square of 7 is 7, or in other words, 7 squared is 49. 7 times 7. Put the negative sign in here, and we have negative 49y squared for the second term. Okay, so that's our answer. Okay, all right, let's look at this one. They want us to factor k squared minus 100. Okay, once again, we notice that k squared is a perfect square and that 100 is 10 squared. So this means we have the difference of two squares, So since we know that we have two squares like this, it's going to factor into this pattern right here, where you have the first square root minus the second square root, and then we have plus the first square root plus the second square root. Okay, so that gives us k squared minus 10 squared equals k minus 10 in parentheses times k plus 10, and that's our answer, because that's that particular expression factored. Okay, and that ends our lesson. So like I said, if you've got any questions at all, bring them to class tomorrow. Write them down on a piece of paper while you still remember them, and we'll get you taken care of before we start any work. Thank you very much. Goodbye.